Let's talk about how we can actually solve this problem with the technique called forwarding. So in forwarding, we do not need to wait for it to be stored in a register. We can use the data as soon as it is available. Okay, just like for example, your mom is preparing food, let's say pasta, on this stove, right? Once it is ready, she's planning to put it in a separate dish and bring it to the dining table. But you figured out that it is already ready and you start eating as soon as it is ready. Although it may make your mom mad, but but this is a way exactly being carried out in this pipeline data hazard strategy. So when do you think the data is available to eat? Right after ALU, right? So x2 plus x3, for example, it is right available after the ALU. So instead of waiting to be served at the dining table or written in the register, we can use it directly from this in this phase. Okay, and that could help us avoid waiting for 2 more cycles. We can avoid bubbles. Yep.
If you had to access memory, would just do it after you access memory?
That is another case, yes. So we will be coming back to that point later. So, but you get it? When the data is available, in this particular example, in the R-type instruction, the data is computed right after the ALU, right? So ALU performed x2 and x3, okay? And x2 plus x3 data is available here. So instead of waiting for it to be written into the register, we can directly use it in the second instruction, in the upcoming instruction. Yep.
So ALU performed x2 and s3, but it doesn't update in x1. The second instruction read data from x1. How could you do that from that phase?
So that's what I'm saying. So it has to write the data into the register x1 in this phase, right? Write back phase. But what we are doing is following a strategy. As soon as the data is available, we use it for the next instruction in this phase. Okay, so which means that we need to have an additional circuitry to deal with this situation. So the circuitry means we need to determine if this instruction is writing into a register, which is a source register in the next instruction. So that is one of the conditions. We will be talking about that point later, but that is a condition. Based on this condition, it will determine whether to read the data from the register or from this. Maybe I can use a term wire, yes. So here you see, this is in reality we have one single processor, right? So it means that the data being generated after the ALU, it should loop back and come back here. Okay, now you can see here we need to decide whether the data must be coming after executing the ALU phase, or must be coming from the register phase. So there are 2 ways now. There are 2 incoming sources for the data for this ALU now. So what do you think we should be putting it here? MUX, simply MUX, which will help us decide whether the data should be coming from the ALU or it should be read from the register, depending on if this condition satisfies. Again, there will be a more complicated condition. Okay, so this is what we call forwarding, or sometimes referred as bypassing. So whenever you see these terms, you do not get confused with what I'm asking you, either forwarding or I can use any term interchangeably. Any question here? So we have talked about that we can avoid data hazards using stalling, okay? But the stalling actually deteriorates the performance because we are just waiting and just wasting the clock cycle. So we employed additional circuitry to avoid waiting. Again, there is a trade-off. Of course, you're employing more resources, but the main goal is to enhance the performance, to speed up the execution. Okay? So forwarding paths are valid only if the destination stage is later in time than the source stage. Of course, when the data is available in this execution phase, you can use it if there is a forward path. Okay, let's say if the data is coming out of memory in the first instruction? What instruction could it be? What instruction produced the data out of memory? LW, load instruction. So in load instruction, so if we replace this instruction from the load instruction, then the load instruction will generate the data here, the valid data here. Agreed? So it will be generating the data around 800 picoseconds. And this instruction requires the data around 600 picoseconds, which means that this would be the path, and this is not a valid path. We cannot use it. So in that case, we must stall. We have to stall. If there is a data dependency between load and the next instruction, even with the forwarding path, we need to stall at least once. Okay? So always remember this. I will keep referring to this again and again. So whenever there is a dependency between R-type instruction, you can avoid it with the forwarding path. But if there is a data dependency between the load instruction and any other next instruction, then we must stall for at least one clock cycle. And why? Because we cannot go back in time. Understand? Any question?